Good morning, boys and girls, and welcome back to day 2 of synthetic division, or division of polynomials. Today we're going to do synthetic division. Again, my name is Mr. Mortara. So let's start and just dive right in here with our synthetic division. All right. Yesterday we talked about long division of polynomials, and we had this big old long process we had to go through. It was a lot of work. We said be real careful with the way you set things up. Make sure you're lining up like terms. It helps to minimize mistakes and to catch mistakes as you're working on it. But this was a lot of work. So hopefully we're saying, hey, sometimes there's going to be an easier way of doing this. Now, not always, but sometimes. Okay. The main thing is when you are dividing by a linear expression. Okay, meaning it is like x plus 2, x minus 3, x plus 1, x minus 4. Something that looks like that. If that is what your divisor is, then you can go ahead and we can use synthetic division. Okay? Now, I don't know if you remember us talking when we did synthetic substitution. Remember synthetic substitution back right around Thanksgiving we did it? And it kind of looked like this, right? These are the same exact problems. One is done with long division, one's done with now with the synthetic substitution or synthetic division. But you can see the amount of work for the synthetic division is a lot less. You guys tend to like synthetic division a whole bunch because it cuts down the amount of work and it really is a nice way to divide polynomials. Okay? The trick again is just emphasizing that it has to be with a linear term. X plus 1, x minus 3, so on. And here's how you would set it up then if we kind of compare these two problems. The divisor is still on the outside. Okay? When we do our synthetic substitution, synthetic division, the divisor is on the outside. What we can do though is what we do is we use the 0 of the problem. If I were to take whatever I am solving and I set it equal to 0, right? Or I've got to change the signs, what you guys say a lot of times. But in this case, I'm going to put a 3 on the outside, and that's for this x minus 3 here. On the inside is going to go the coefficients of my dividend. Okay? So 2, negative 5, negative 8, 15. 2, negative 5, negative 8, 15. Right? So the dividend still goes on the inside, but now it goes on the inside and it's just the coefficients, looks like that. And now we're going to do our normal synthetic substitution like we did before. I bring down the first number, quick little review here. We multiply, I get 6. I add, negative 5 plus 6 is 1. I multiply, add, multiply, add. That should be negative 5 times 3 is negative 15. Caught a mistake. But when I add, I get 0. And so that works out correctly. Okay? And then we get 0. So we have, again, this last number we get. Remember, this was the number that we got when we plugged into the equation. Okay? But this is also known as the remainder as well. And in this case, we don't have remainder. And now we just need to interpret what is left over. All right? These numbers left over are the coefficients of our answer. Because we divided x cubed by x, we're going to go down. And we're always going to divide by x because this had to be a linear divisor. When I divide that, this becomes 2x squared plus 1x minus 5, and we didn't have a remainder. And if we go back and look at our quotient here, at our answer, 2x squared plus x minus 5. Hey, what do you know? Those are the same things. So we can use the synthetic substitution, this synthetic division, to make our division problems a lot easier, a lot nicer. All right, let's jump in and let's kind of see actually how this works in action now. All right, number 1. If I want to divide this using synthetic division, again, first thing, I need to make sure that it is a linear divisor, and it is, so we're good to go. I'm going to set it up using my giant L for synthetic division now instead of the, my upside down dividing sign, instead of the one we used before. On the outside, I'm going to use the 0. So x plus 2 equals 0. So x equals negative 2. Or you can just remember you have to change the sign. So a lot of people, it's a plus 2, so I got to change the sign. It's a negative 2. On the inside, I'm going to put just the quotients. Or I'm just going to put just the coefficients of my dividend. 1, 4, negative 5, 3. When I'm doing that again, just like before, I'm being very careful. If I were missing a term, just like yesterday, if I'm missing a term, I need to add a 0. In this case, I'm not, so I'm good to go. And now we're going to do our synthetic division just like normal. Bring down the first one. Multiply is negative 2. Add is 2. 2 times negative 2 is negative 4. Add, I get negative 9. Negative 9 times negative 2 is positive 18. Add, I get 21. Now in this case, I don't, it didn't equal 0 like the example above, but that's okay. This here is still my remainder. Alright? This now is just my answer that I need to interpret. Okay? This was an x cubed to begin with, and we divided it by an x. So just remember, you're always going to go down 1. If it started to be an x to the 4th, like down here we start with an x to the 4th, my answer would start with an x cubed. Okay? If I started with an x squared, my answer would start with an x. Okay? Because we start with an x cubed, this becomes 1x squared plus 2x minus 9. You should always end with a constant, so that's good. And then my remainder now, plus, and just like we did before, the remainder is going to go on top, and then what I divided by. Now what we're really dividing by is x plus 2, so that's going to go on the bottom. So x squared plus 2x minus 9 plus 21 over x plus 2. I could do this same problem with a long division we did yesterday. It's just that work is way nicer and happier to do, so we prefer to do it that way. Alright, let's move on to number 2. Number 2, 2x cubed plus 3x squared minus 6 divided by x minus 3. Alright, so setting it up, we're going to do synthetic. So giant upside down L. On the outside, I need to use the 0, so I'm going to change the sign and put a positive 3. On the inside, I'm going to put the coefficients 2, 3. In this case, we're missing an x term. So very important. This is the most common place we mess up, is we forget to put that 0. And then negative 6. Alright. Now I'm going to do my synthetic substitution, aka synthetic division. Bring down the first number. Multiply. Add. That is not adding. That was multiplying. I need to add. Add. Multiply. Add. Multiply. 3 times 27, oh, getting bigger, is 81. This is where you might want a calculator sometimes to help with the multiplying and the adding. 81 minus 6 is 75. Alright. Then again, I kind of like to do that to section off my remainder. Now, again, I started with an x cubed term. So, this is an x squared. 2x squared plus 9x 7. Again, the fact that that ended off with my remainder with a constant number, that's what I'm looking for. And then so plus 75 is my remainder over what I divided by, x minus 3. Alright, easy peasy lemon squeezy. Again, today you tend to like a lot better than the first day of the long division. Long division's a little bit tougher. Now, again, the reason we still need long division though, going back, if we look at yesterday's notes just real fast on what we did yesterday, why didn't we always use synthetic? Well, synthetic, again, is only good if you're dividing by linear number. If we look at our work from yesterday here, so like number 3, I could have used synthetic division, and that would have made that a whole lot nicer. Number 4, though, and number 5, because I'm dividing by an x squared, I could not use synthetic division. This is a problem that has to be done with long division. Same with 5. Because we divided by an x squared, that is a problem that has to be done with long division. Alright? So synthetic division is great, and it's going to be what we use most of the time. We do want to be very good with synthetic division. However, I can't always use synthetic. There are going to be times that I still need to use long division, so don't completely forget long division altogether. All right? Next one now. Upside down L. I need to change the sign, so positive 1 on the outside. 3, I don't have an x cubed, so again I need a 0. Don't forget it. Negative 7, 14, negative 9. All right? Setup is relatively straightforward and simple. Bring down your first one, 3, multiply, 3, add, 3, multiply, 3, lots of 3s, add, no more 3s, negative 4, multiply, negative 4, add, 10, multiply, that's 10, and then add, I get 1, and again, that last guy is my remainder. This one's a little bit different, not just because it's a little bit longer, but same idea. This is my answer now. That is my remainder right here. And because I started with an x to the 4th, I now need to start my answer with an x cubed. 3x cubed plus 3x squared minus 4x plus 10. Again, when you get here, you should always end with that constant term. That makes me feel good. This last one is my remainder, plus 1 over x minus 1. And there's our answer using synthetic. Easy peasy lemon squeezy. All right? Very last one. I'm going to say, I've done 3 of them now. I want you to set this one up and try this one on your own. So go ahead and pause the video. Give yourself about, a minute or 2 minutes to do the problem. And then come back and hit play and check yourself. See you in a sec, boys and girls. Okay, if you look at your work, it should look something kind of like this. You should add 7, negative 14, and 4 on the inside, negative 2 on the outside, bring down the 7, multiply negative 14, add negative 28, multiply 56, add 60. And that 60 is my remainder now. So we started with an x squared, so this should be a 7x minus 28 plus 60 over x plus 2 should have been your answer. All right, boys and girls, that is synthetic division. Again, ask your teachers if you've got questions. Otherwise, get after the homework and have a great day.